In this video, we'll go through every main light type inside Unreal Engine, point, spot, rect, and directional with Skylight. I'll show you what each one does, how their settings work, and how changing just a few values can completely transform the look and mood of your scene. Whether you're after something cinematic or totally stylized, by the end, you'll know exactly how each light behaves and when to use it. Alright guys, I'm starting with the first-person shooter template in Unreal Engine 5.6. This level is perfect for lighting tests. It already has clean geometry, ramps, and neutral colors that make light behavior easy to see. Now I'm going to add our reference model in the content browser, under characters, under mannequins, under meshes. I'm using SKM Quinn Simple. Drag it right into the center of the ramp to make sure it's exactly centered. Open the details panel, go to transform. Set X to 0, Y to 0, and keep Z at 210. That height keeps the mannequin slightly above the ground so we can clearly see the light and shadow changes later. Next, we need to fix one important setting before adding new lights. Go to Edit, Project Settings, and search for Exposure. Under Engine Rendering Default Settings, you'll find Auto Exposure turned on by default. Auto Exposure simulates how your eyes or a real camera adjust to light. When the scene is dark, Unreal brightens it, and when it's too bright, it darkens automatically. That's fine for gameplay, but for lighting tests, it constantly changes the brightness and makes it impossible to compare results. So turn auto exposure off. Now the exposure is locked and we have full manual control over the lighting. With that done, let's clean up Unreal's default lighting setup. In the World Outliner, open the lighting folder. You'll see Directional Light, Skylight, Sky Atmosphere, Volumetric Cloud, Exponential Height Fog, and SM Sky Sphere. Select all of them and delete them. Your level will turn completely dark, and that's exactly what we want. From now on, we'll add every light ourselves to understand what each one does. Here's the plan for the rest of the video. We'll start with the point light, then move to the spotlight, after that the rect light, and finally we'll combine the directional light and the skylight together for our daylight setup. By the end, you'll understand how every light type works on its own and how they blend together to create realistic lighting. Alright, now let's start with our first light, the point light. Go to the Place Actors panel, open the Lights category, and drag a point light into the scene. I'm placing it right above the mannequin so we can clearly see how it spreads light in every direction. Think of the point light like a small bulb that glows all around itself. It doesn't have any direction, it just emits light evenly in a full sphere. Now, let's open the Details panel and take a look at its settings. First, we have the intensity. This controls how bright the light is. If you lower it, the light becomes softer and dim. If you increase it, it gets much stronger and can easily overexpose the surface. Right now, mine is set to around 100 lumens. Try raising it to a few hundred or even 1,000 and you'll see the entire area brighten up. Next we have light color. This one is very easy to test. Click the color box and try a few different tones. Let's change it to red first. You'll notice how the whole ramp and the mannequin's body reflect that red tint. Now switch to green. And finally to blue. Each color gives a completely different atmosphere and helps you understand how light color affects your scene mood. The next important control is attenuation radius. This defines how far the light reaches before it stops affecting objects. When you lower it, the light only covers a small area under the mannequin. And if you increase it to around 16,000, it spreads much wider and lights up the background walls too. This radius is really useful when you want to limit how far the light travels in the scene. Then we have source radius. By default, it's set to 0, which makes the light act like a single pinpoint. That gives us very sharp highlights and strong shadow edges. If we increase it to something like 50, the shadows become softer and more natural. And this setting is great when you want your light to feel less harsh, like from a lamp with a big bulb. Below that is source length, which stretches the light along a line. If you imagine a fluorescent tube, this parameter controls that kind of effect. When it's 0, the light is a dot. If you set it to around 200, the highlights become longer and shadows blend smoother. The next option is use temperature. When enabled, instead of picking colors manually, you can control the warmth or coolness of the light using temperature values. For example, a lower temperature like 3000 Kelvin gives you a warm yellow tone, while something around 6500 Kelvin gives a neutral daylight feel. Affects world simply decides if this light should actually affect the scene. If you uncheck it, the light will stop illuminating anything, which is handy when you want to preview lighting setups without deleting lights. Cast shadows, as the name says, determines if this light should generate shadows. If I turn it off, everything becomes evenly lit and the mannequin loses its contact with the ground. When I turn it back on, shadows reappear and the scene feels more grounded. Indirect lighting intensity controls how much this light contributes to global illumination, basically how much it bounces off surfaces. Keeping it at 1 is standard, but you can increase it to 2 if you want more bounce light filling darker areas. Now let's scroll down to the advanced section. You'll see an option called Use Inverse Squared Falloff. When this is turned on, the light behaves physically accurate, meaning brightness falls off naturally over distance, like in the real world. When you disable Use Inverse Squared Falloff, Unreal lets you manually control how quickly the light fades using the falloff exponent setting just below it. A smaller number makes the falloff smoother, while a higher number like 8 makes it drop sharply. And here's something important. When you disable this option, Unreal automatically switches the intensity units from lumens to unitless. So, if you want to go back to the normal, physically accurate behavior, simply turn the checkbox back on and make sure to also change the intensity units back to lumens, luminous flux. Otherwise, your light will stay uncalibrated. Specular scale controls how shiny the reflections appear on surfaces. Lower values reduce glare and reflections, while higher values make them pop. Try setting it to 0.5 for a softer look or 1 for a stronger highlight. Shadow bias and shadow filter. Sharpen help fine-tune shadow accuracy. If you ever see strange artifacts or flickering shadows, adjust the bias slightly higher to clean them up. Sharpening makes the shadow edges crisper. And finally, contact shadows add those subtle little grounding details where feet or objects touch surfaces. If you raise the contact shadow length, you'll see a small, soft shadow directly under the mannequin's feet that makes everything feel more connected to the ground. So to summarize what we've seen, point light is perfect for local sources like lamps, candles, or energy cores in sci-fi scenes. It lights everything around itself equally. It's easy to control, and with these parameters you can create anything from a tiny bulb glow to a large area fill light. Keep the radius and intensity balanced, use source radius to control softness, and remember that color and temperature define the overall feeling of your scene. Alright, let's move to the spotlight. First, I'm deleting the point light so we can clearly see what the spot is doing on its own. From the Place Actors panel, Lights category, I'm dragging a spotlight into the level. I'm placing it above the mannequin so the cone points straight down at the center of the ramp. A spotlight is basically a cone of light coming from a single point. Inside that cone, there are two important angles that shape the beam. Outer cone angle controls how wide the beam spreads. If I increase the outer angle, the beam opens up and covers a larger area. If I lower it, the beam becomes tight like a flashlight. Inner cone angle defines the hot spot in the middle. Everything inside the inner angle gets full brightness. Between the inner angle and the outer angle, you get a smooth fall off, a soft feather that fades toward the edges. If I set the inner angle to something like 30 and the outer angle to 60, you'll see a bright core with a gentle penumbra around it. If I push the inner angle almost as wide as the outer one, the edge becomes harder and the hot spot almost fills the whole cone. Attenuation radius sets how far the beam can reach. Think of it as the length of the cone. If the radius is too small, the light will die before it hits the ground. If I raise it, the cone reaches the floor and the walls, and you'll see the footprint expand. Intensity is the overall brightness of the light. If it's too low, you'll barely see the beam on the floor. If I raise it into the hundreds or thousands, the center becomes very bright and the fall-off becomes more obvious. For physical behavior, keep the units on lumens or candela. Lumens describe total light output, while candela describes intensity in a given direction, which can be useful for tight, focused beams. Light color is great for quick visual testing. I'll switch to red, then green, then blue. So you can see how the cone picks up that tint across the ramp and the mannequin. Source radius and soft source radius. help shape specular highlights and the softness of the edge. At 0, the edge looks crisp and the highlight is small. If I increase source radius, the shadow edges and the highlight get softer and more natural. Soft source radius further blurs the specular hotspot if it feels too sharp. Source length stretches the emitter along a line. If I increase it, the highlight looks elongated, similar to a tube or a bar light. Use temperature lets you control color using Kelvin values instead of picking a color. Lower temperatures feel warm and yellow, higher values feel neutral to cool. Effects world and cast shadows are simple toggles. If I disable affects world, the light stops contributing without deleting it. If I disable cast shadows, the cone still lights the surface, but there's no shadow from the mannequin, which makes the scene feel flat. Turning shadows back on restores the grounded look. That's the core of Spotlight. Use it when you need focused, directional pools of light, stage lighting, flashlights, street lamps, or any situation where you want a controllable cone with a bright center and a soft edge. Dial in the outer angle for coverage, set the inner angle for the hotspot, adjust the radius so the cone reaches your subject, and then shape the softness with the source settings to taste. Alright, now let's move on to the Rect light. I've deleted the spotlight and dragged a Rect light into the scene. Instead of placing it above the mannequin, I'll move it to the side and angle it across the ramp. Rect lights are perfect for soft wide lighting, like the kind you'd get from Windows, LED panels, or TV screens. Because this light actually has width and height, it produces smooth shadows and softer highlights compared to point or spotlights. Let's take a look at the settings. The intensity value controls how bright the light is overall. If it's too low, the mannequin barely lights up. If I raise it higher, the whole side of the character and floor start glowing. This light is using lumens, luminous flux, which means it follows real-world brightness values. You could switch to unitless mode, but that's mostly for legacy projects. Lumens are far more accurate for realistic lighting. Next is light color. This simply tints the light. I'll switch it between red, green, and blue, and you can see how the entire surface picks up the color. For daylight looks, keep it white or use temperature instead. The attenuation radius defines how far this light reaches. Think of it as the light's maximum distance. If I lower it to 500, the light fades out quickly. If I push it up to 2000, it covers a much wider area. Try to keep this value only as large as you need. Bigger values can affect performance. Now, the key part of the Rect light is source width and source height. These control the physical size of the light panel. If I shrink them down, the shadows become sharper and more focused. If I make them larger, shadows get softer and the reflections spread out. That's why Rect lights are great for natural soft illumination. Next up are barn door angle and barn door length. These act just like real film light barn doors. They let you cut off the edges of the light and control how much spill hits nearby surfaces. If I increase both values, the beam tightens and becomes more focused. If I lower them, the light spreads wider and fills more of the scene. Use these when you need to shape the light coming from a fake window or a studio panel. Now, source texture. This one is fun. You can assign any texture to the emitting surface. For example, I'll pick a green icon first. You'll notice the light immediately turns green and slightly picks up that pattern in reflections. I'll switch to a red icon next, and now the light has a completely different mood. On shiny materials, you can actually see the texture reflected, while matte surfaces mostly just catch the color. This is perfect for things like TV screens, monitors, neon lights, or patterned panels. Use temperature allows you to control color based on Kelvin values. If I enable it and set around 3000 Kelvin, the light becomes warm and orange like a tungsten bulb. At around 6500 Kelvin, it's bright white daylight. You can still combine this with the light color setting if you want to fine-tune the tone. Affects World simply turns the light's effect on or off without deleting it. Useful for quick comparisons. Cast Shadows does exactly what it says. When it's off, the light still illuminates the scene, but nothing casts a shadow. Turn it back on and you immediately get shape and realism back. Indirect lighting intensity controls how much this light contributes to bounce light, basically global illumination. Leave it at 1 for realistic results or increase it slightly if you want to brighten darker areas. Volumetric scattering. Intensity defines how strong the light appears in fog or volumetric effects. Right now we don't have fog in the level, so you won't see much difference, but if you add exponential height fog later, this setting will make the light beams visible. A quick note about mobility. When a Rect light is static or stationary, Unreal calculates soft area lighting accurately when you build lighting. When it's movable, like in our case, it behaves more like a point light for direct illumination but still uses its rectangle size for reflections. That's why movable Rect lights are more flexible for demos like this, but a bit heavier on performance. So, to sum it up, place your Rect light where a real soft light would be. Adjust the width and height for softness, use barn doors to control spill, set intensity and radius to fit your scene, and if you want some extra style, apply a texture or color temperature. Alright, now let's move to the final lighting setup. I've deleted the Rect light and opened Window from top menu. Then ENV Light Mixer. This panel lets us create the full environment lighting system with just a few clicks. From here, I'm creating a skylight, a directional light, a sky atmosphere, volumetric clouds, and height fog. Once you add them all, Unreal automatically connects everything together: sun, sky, clouds, and fog. Before touching any settings, remember this shortcut. Hold Ctrl+L and move your mouse. That rotates the sun in real time. It's one of the most useful shortcuts for adjusting sunlight direction and mood in your scene. If you see that orbital guide around your light, it means it's ready to rotate. Now let's break down the settings one by one. Before we continue, let me clean up our outliner and drop these new actors inside lighting folder. The directional light acts like the sun. Its position doesn't matter, only the rotation does. The intensity value controls how bright the sunlight is. It in lux units for realistic outdoor lighting. A value around 10 is a good start for daytime scenes. Light color changes the color of the sun. Slightly warm tones give a sunrise or sunset feel, while cool tones feel more like midday. Indirect lighting intensity boosts how much bounce light the sun adds to the environment. Leave it at 1 for realistic energy, or increase it slightly if you want brighter ambient fill. Volumetric scattering intensity controls how strong the light appears inside fog or clouds. When you see visible light beams, this is the value that drives them. Under atmosphere and cloud, we have cloud scattered luminance scale. It adjusts how bright the sun appears when scattering through clouds, and if your clouds look dull or overblown, this setting is what you tweak. You can also enable atmosphere sunlight on this light so the sky atmosphere treats it as the main sun source. That's how it knows where to cast the sky's color gradient and scattering. The skylight captures light from the sky and fills the shadows. It's what gives your scene realistic ambient color. Intensity controls how bright that ambient light is. Light color tints the fill tone. Usually it stays neutral white or slightly blue. Indirect lighting intensity affects how much of this light bounces across surfaces. Volumetric scattering intensity defines how visible it is in fog. If you scroll down, you'll see distance field ambient occlusion. This adds large-scale soft shadows in areas where light can't easily reach. You can adjust max distance, exponent, and occlusion tint to get more realistic depth and shading in open areas. If you're building a dynamic day-night system, make sure your skylight is set to movable and real-time capture is enabled. That way, it keeps updating as the sun moves across the sky. The sky atmosphere simulates how sunlight scatters through the atmosphere. That's what gives you a blue sky during the day and red tones at sunset. Ground albedo controls how much light reflects off the ground and back into the sky. Multi-scattering makes the atmosphere richer by bouncing light multiple times, giving a more realistic color gradient. Then we have the Rayleigh section. Rayleigh scattering scale defines how much the tiny air molecules scatter light. Lower values give a deeper blue sky. The Rayleigh scattering color can be tinted if you want stylized skies. Below that is the Mi scattering section. This one controls haze and dust in the air. Mi scattering changes brightness. Mi absorption scale controls how much light gets lost in that haze. Mi anisotropy pushes light forward, creating that glowing halo around the sun when it's near the horizon. Then there's absorption. That one defines how much light gets absorbed by the atmosphere, changing the warmth or coolness of the sky. For a clear day, keep the absorption low. For heavy haze or pollution, push it higher. Finally, the art direction section. Here you can control the overall brightness of the sky, how much fog reacts to the atmosphere, and at what distance aerial perspective begins. These are great for fine-tuning cinematic shots. Volumetric clouds. The volumetric cloud component adds real 3D clouds that move and react to sunlight. Layer bottom altitude sets how high the base of the cloud sits above the ground. Layer height defines how thick the cloud layer is. Tracing start max distance and tracing max distance control how far clouds render and how dense they look. Smaller numbers mean faster performance but less depth. Ground albedo affects how much light from the ground bounces into the clouds. And the cloud material lets you use custom shaders for stylized skies or weather systems. Exponential height fog. This one adds that beautiful atmospheric depth that fades objects into the distance. Fog density controls how thick the fog is overall. Fog height fall-off determines how fast it fades as you move higher. Fog in scattering color tints the fog. For natural daylight, keep it slightly bluish. Start distance defines where the fog begins from the camera. A small value wraps fog right around your view. Fog cutoff distance limits how far the fog extends into the world. Then we have directional in scattering. This connects your sunlight to the fog, giving that glowing beam effect when the sun shines through. Finally, check volumetric fog to enable true 3D volumetric lighting. When this is active and your directional light has volumetric scattering intensity turned up, you'll see proper God rays and light shafts across your scene. And that's the complete environment lighting setup. We've got the sun, the sky, the atmosphere, the clouds, and the fog, all working together. With Ctrl+L, you can rotate your sunlight, adjust intensity and fog density, and instantly switch from clear day to dramatic sunset. This combination gives you a fully dynamic cinematic lighting system inside Unreal Engine. Alright, that wraps up our full lighting setup. From point and spotlights all the way to directional and skylighting. I hope this helped you understand how each light works and how they come together to make your scene looks good. If you found this video useful, please drop a comment, leave a like, and subscribe to the channel. It really helps me keep making more Unreal Engine tutorials like this. Thanks for watching, and I'll see you in the next one.